Okay, so today we will start chapter 5, and then in this we will be learning how to control the access to the files. So in the last session, we have seen the importance of users, groups, and how to give the user additional privileges using sudo and all those stuff, right? So now that part is done where we have users and all those stuff. Now I want to give them the required access, like probably user one wants to access a particular folder and user two wants to access a particular folder, or if the team if the people if a group of people are working in a team, they would require
Mhm.
access to a common folder, right? So there, then I'll create a group, add those users into the group, and then I will change the group permissions on the file system on the folder, so that the entire group can access the files. Okay, so those are the things that we will be covering in this particular chapter, right? How to control the access. Now, right now, file permissions. So when we work on files, right, permission plays a vital role. We need to know, uh, you need to understand which user should have a read access, write access, and which user has needs read-only access, and all those stuff. You need to understand and then get approval, and then you need to then you need to assign those proper permission to the user or the group, right? So you have user permissions and you have group permissions, both, right? So for every file and folder, whether it is an executable file or a normal file, any file or folder, you have user permission and group permission, right? And apart from user and group, there is also one more section for other users, like users are groups you commonly know, right? So any users apart from apart from the mentioned users and group, they all fall under others category. Okay, they are fall under others category. So generally, when you talk about permission in Linux, it is user, group, and others. Three sections. And what are those three sections? How it works? We will see in the lab. Okay, you can set different permissions for each user category. So we have three categories: user, group, and others. In these categories, you can assign permissions, like whatever permission, like owner might have full permission, group might have only write permission, others might have only read permission. So we will see, look at those permissions, right? So now, when you talk about this three, what do you call categories, right? User, group, and other. There are again some properties, that is read, write, and execute. Okay, so these are self-explanatory, right? If you give read, the person will be able to read. If you give write access, the person will be able to write the contents inside the file, or he can create, delete the files. And the other option is execute. X stands for execute. So files can be executed as commands. Like yesterday, I mean, we have seen few commands, right? ls, mv, cp, and all those stuff, right? Those are executable files. They have X, so that the file will be executed. So basically, when you give execute, that files are not normal files, those are scripts, right? So it can be a Python script or shell script, or it can be any script, right? So if you want to execute a script, then we give, execute access. Okay. So read is R, write is W, execute is executed. Right? Typically, users have both read and execute permissions and read only directories, so that they can list the directories and all the stuff, right? So again, it all depends upon what permissions you give on a particular file or a folder: read, write, and execute. Right? Anyone who owns or has both read and execute permission on a directory can remove files from it. And again, it's a permutation combination based on the permission that you give, whether it is read, write, or execute, or read, write, read, execute. We will see how to give those permissions. So based on the permissions that you assign, you can uh, create the permissions. Also, there is one more behavior called sticky bit. So currently you have seen three octets, right? Read, write, and execute, right? So there is another category which we will be covering in this chapter, which is sticky bit. Sticky bit, SGID and SUID. So I show you what is the purpose of those and how to apply them. Right? So again, these are all the choices that are available. How you can give permissions to a file. Again, it depends upon the requirement. You can assign any permissions you want based on your requirement. That is how you can make sure you can give the assign the right permissions to the users or the particular folder. Okay, right? Again, it's the same thing. Modify again. These are all normal. What do you call uh, theory. You don't have to go into that actually. So basically, you have read, write, and execute, and it can be on a folder or it can be on a user. And there are three categories. Those are user, group, and other. So these are the things that you need to remember when working on the what you call working on a particular uh, files. Right? Now, how do you identify the permissions of an existing file? Okay, so viewing file and directory permissions and ownership. Now, the command is ls-l. So with ls-l, you will see, and you can provide the folder name or file name. ls-l folder name or file name. That will give you the scenario, right? Permissions. Now, let's analyze these permissions. Right? Now, when you have a single file, if you want to know the permission of a single file, you just say ls-l test. But if you want to know the permissions of a directory, then you have to use capital D. Remember. So capital D will show the permissions of the folder. If you don't give -D, it will list all the files inside the home directory. But my purpose is I want to know the permissions on this folder. I don't want to list the files inside the folder. So if you don't give -D, it will list the contents of this folder. Okay. Since I wanted to know the permissions of this /home folder, the command is ls-l d/home. Right? So this is for a text file. This is for a directory. Right? Now, this is where the permissions will come into picture. The first 3 plus 3 plus 3, 9, 10 octets. So you have 10 octets here. So 10 octets represents the permissions. And these 10 octets, right, it is divided into three parts. So RWX, 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 3, 3, 3. So we have seen three categories, user, group, and other. So one extra is an extra character, right? Extra octet. Right? Now, here, the first octet, if you see a hyphen, it is a directory. I told you, right? With the help of the first octet, you can tell the type of the file. Okay. So if the octet is a hyphen, it is a regular file. If you have a D here, that is a directory. If you have a L, which is a symbolic link. Okay. If it is C, it's a character file. B is block file. P is pipe file. S is socket file. Right. So these are all the system related files. Character file, block file. So character file and block file, those are the storage. And piped file and socket file are meant for your uh, services on your machine. Right.
Okay.
You don't have to worry about what is socket file, what is pipe file. Basically, socket file is a file which is used by the processes. Like if you run, I'll give you an example. Now, if you run an Apache service, Apache is a web server. Okay. So if you run
Mhm.
web server will create a socket, right? A socket is a process which opens up a particular port on the server, right? So socket is the way how you can expose your service to the external world. right? Whether it is a web server, database server, or Docker server, whatever it is, right? It opens up this socket, right? So that is socket. Pipe file is the name itself indicates pipe is the output of one file will be sent as an input to other files. So you can pipe the files, or you can combine two files to run a complex task. So basically, this will be done by the your regular operating system kernel level activity. So you don't generally do this unless you are a programmer, right? So we don't usually work on pipes and sockets. Okay, only developers and DevOps team they work on operators. But because these are all kernel level activities. Right? Block file character files is your disks, hard disks. It can be your NAS volume, SAN volume, or it can be NFS volume. So you can write, these are all your volume types. So likewise, you can identify the purpose of your file. Okay,
Sure.
right? Now the next nine characters. So first character is done, first octet is done. The next nine characters. So the next nine characters are read, write, and execute. Okay, right? So read, write, execute for owner, users, and sorry, users, groups, and others. So 3 plus 3 plus 3, which is 9. Right? So, and now if you look at the permissions, right, you can change the permissions as you in whatever way you want. Okay, so generally, probably I will open up Notepad. Right? So if you look at this permissions, right?
Mm-hmm.
Let me bring this. Yeah. So here you have permissions, right? Now generally what happens here is now let's say you have a file. Okay, I have file one. Okay. Now file one, the owner. Generally, you can interchange owner and the user. Okay, you can interchange owner and user. Okay. Now, for a file, I have owner and the user, and I have group, and I have others, right? Others.
Mm-hmm.
Now, every entity category has read, write, and execute. Okay. So every user, group, and other has read, write, execute. Okay. Right. Read, write, execute. Now, let's say for this file, let's say the owner is Arvind, okay, and group name is RH199 GRP. That's a group name. Okay, so
Mm-hmm.
I want the owner to be Arvind, the file owner to be Arvind, and group is RH199 group. Now,
Mm-hmm.
my requirement is I want Arvind to control the file fully. Okay, to control the file. That is full access. I want Arvind to give a full access on this particular file. Okay, and then
Mm-hmm.
let's say I want this group. Okay, RH199, RH199. Okay. So RH199 group to only write, okay, write access. And then I want others to only read, read permission, right?
Mm-hmm.
And generally, what is the permissions how many octets we have? 10, right? 1, 1, 2, 3, 1, 2, 3, 1, 2, 3. Total 10, right? So this is
Mm-hmm.
pulled out, which is our directory or block or whatever the file type. So first three octets is for user, group is 3 RWX, and others equal to RWX. Now, what is my requirement? I want Arvind to give full access. That is, he should be able to read, write, and execute. Okay. So I will say read, write, execute. Then what my group should have? Write access.
Only write permission.
So
Yeah.
generally here what I will do, I will, because write is second option, right?
Mm-hmm.
Right. So I will say write. And others, I need only, read access. Okay. Right. So I will give read access. Got the permission? Got the access? Understood this one?
Got it.
Now, similarly, there is one more requirement. Anyways, user is full access. Anyways, Arvind will have full access, the user. Now, I want the group to have read write. So what do? Read, write, hyphen. And I don't want to give any access to the other users. They should not see my files. So I will say this one. Got it? So
Got it.
here, any other users in the system other than Arvind and the members in this group, they cannot view the files inside my directory. They can't read, they can't modify, they can't view the files. So it all depends upon how you want to assign the permission based on your requirements. Okay. And this, if you want to change, right, there are different ways that you can choose. Okay. First one is you can, if you want to, again, we will look at the comments later. I'll tell you the comments. Now, there are values assigned to this default variables. Read, write, execute, right? So
Mm-hmm.
read is given a value of 4. That's a default. Okay. Write is given a value of 2, and then execute is given as 1. So total it is 7. The count is 7. Okay. So this should be your permissions. So when you change the permissions, which we will see in a moment, you can use RWX directly to change the permission, or you can use the numerical value. Now, if how do you convert this one or this one? What should be the value? So the file name is
So
7, then write
two
is
four
2, and read is
four
4. And what about the second one? 7 and read write 4 plus 2,
six.
6, and nothing on others, which is 0.
Yeah.
Likewise, you need to calculate and you need to assign the permissions. Right? So how do we give all those things? We will see now. Okay. So now you have permission. See, you have read write. So read write. Okay.
Mm-hmm.
And permission synergy. I told you, right? You can create users, you can create groups, and you can assign the groups to the files and directories, whatever you want. Okay. Now if you observe, now we can play around here, right? See, now I have app1.log. So who is the owner of this file now?
Operator.
Operator 1. And who is the group? Operator 1 again. And for
One.
app2.log, the owner is operator 1 and the group is consultant, right? And if you observe,
Mm-hmm.
my operator 1 user can read, write this app2.log file. Okay. And my group, consultant 1 group, can only read this app2.log file. And other users can read and write. Other users apart from these two, they can read write this file. Okay. So likewise, you can give assign permissions to the file system. Okay.
So what are those numbers over there, Arvind? The 4096,
It's the
4096.
size of the file.
Okay, okay, size of the file, okay.
So actually, if you observe, I'll increase the time. And now you can, when you say ls hyphen l hyphen l, so this is the size actually. Okay. Now you can also say ls-lh. See, 2.7 kilobytes,
Oh,
right? But here these are very, very small files. That is why 6 bytes. These are all 6 bytes. And this is 2676 bytes, which is 2.7 K. That's the size. Okay. So LH will give you the size in the H will give you in human readable format. Bytes, megabytes, and gigabytes and all those stuff.
okay.
Okay. Now, now, so this is fine. This is how you can give the permissions. Right. Now you need to change the permission. So how do you change it, right? Again, there are a lot of scenarios. I told you, right? This is a scenario. Someone will ask you, this user should read, right? This group should have read only. Others should have so and so. The logic will not change. The requirement will change. Right? They will give you 10 requirements, but the only logic you can use it are WX based on the requirement. You can assign the permissions. Right? Now, now we'll see the scenario, like how we can change. Again, this is a small quiz. You can go through the quiz, which is fine, right?
Mm.
And again, I told you, right, these numbers are very, very important. So this one slider, right, you will be using throughout your career. If you are in IT industry managing Linux, you have to remember this, right? So you should not forget, and this number should be on your fingertips, right? Now, this is a solution you can go through. Now, managing file permissions on the command line. So now, how do you manage the permissions through command line? Okay. So now, changing the permissions, the command is chmod, change mod. So chmod is the command that is used to what we call change the permissions of a file. And chmod followed by who, what, which, the permissions, and then it can be directory or file. Okay. Now, as I told you, right, there are three categories, right? User, group, and other. I told you sometimes they call user and sometimes they call owner. So these two are interchangeable. Owners and groups are interchangeable, right? So, and for the user, the name is U, group G, O is other. So here for the owner, the what do you call uh, the convention naming convention is U, and for group it is G, and for others it is O. Okay, user, group, and others. So, and this is the one, either you can use this or you can use it. There are different methods which you will see now. Okay, so user, group, and other. So you have UGO, you have RWX, right? Now again, A is for all. So there is one more category which we have not discussed, which is A. A is for all, which includes everyone in the machine. It can be you, it can be me, or it can be anyone in the machine. All will have the access. It's open to everyone, right? Now, now you know the category names, and you know the permissions, and you know the command. What is the command? Command is chmod. Chmod is the command.
Chamor.
Right. So now, how do you use chmod to assign the permission? Again, for the chmod, you have plus, minus, equal to. So plus is you can add permission, minus you can remove, and equal to is it will set. I don't care what are the existing permissions. Reset the file with whatever I give with equal to symbol. Simple. Right? It simply changes the file properties, and it doesn't care. I don't care what are my existing file permissions. And
Mm-hmm.
again, this is a choice. You can either use this, or this, anything. Ultimately, as I told you, no one will ask you the command and procedure. They will look at the outcome, whether the file has changed or not. They will look at the outcome. You can use any one of these, plus, minus, equal to. right? Now I told right, mode is RWX, operator is plus minus equal to, and user class is user group other. So UGO, RWX, and plus minus equal to. So with these three sections, we will try to change the permissions. You can also use capital X also execute permissions to a directory. So small x is a file, capital X is for a directory. You can use that also. Okay?
You can use the numbers instead of this
Yeah,
whole thing, right?
we will see that in a moment. Now, how do you change the permission? Right? The command is chmod, and now how do you represent this now? Can you elaborate?
Of course, it's a group, it's others.
Others, and
Read write permission.
what we are doing with this command?
We're giving group as a read permission and others for the write permission.
No, this symbol, that is important.
It's
Minus,
an hyphen, right? We are not giving any permission for the but
remove, minus is remove.
oh,
Ah,
okay, okay, okay.
not a
Okay.
hyphen. That's why I asked.
Okay, okay, okay.
So minus
Minus,
is
okay.
remove, plus is add, equal to is whatever I
Right, right.
give here, it will automatically, whatever GO equal to RW, I don't care what it has. For group other, it will redirect. So this command indicates on this PDF file, I am removing the read write permissions for group and other users.
Okay,
And chmod A plus X. A stands for all. Plus,
okay.
I am adding execute for all the users on this script so that anyone in the machine who logs in, they can execute this script. X is execute, right? Now,
Mm-hmm.
and also, if you are setting the permissions on a folder, and if you want to simulate the folder permissions onto the underlying files, you will use hyphen capital R. R is for recursive. So I am adding group permission, that is group should have read, write, execute, right? And then recursively, whatever this folder has, how many, whatever number of files this folder has, I don't care. You just give read, write, execute permissions on all the files inside this folder. So with the help of recursive, it will do that. If you don't give recursive here, it will assign this permission only to this parent folder, not to the underlying files.
Mm-hmm.
Okay. That is hyper R recursive option. Right? And you can also use plus X because you are using a directory, right? So directory you can
Yeah.
plus X. So chmod hyphen capital R, G plus RWX and the demo directory. Right? That is how you can change the permissions with chmod. So changing permission with octal. Now we have used this, using this characters, right? G, R, and X, right? So you can also use the chmod using the values, right? 3-digit octal number. So I told you, right? So where the octal digits varies from 0 to 7. Right? And see, I told you, right? Binary conversion 4 plus 2 plus 1 equal to 7. So if you want to give read write, the permission will be 6, 2 plus 4. If you want to only give read access, it is 4. Read access 4. So that's where you can change. Now, how do we use these values? Right? So for that, we use chmod 644. What does this mean?
Read, write, read, read.
Yeah, so owner will have read write, group will have read only, others will have read only.
Yeah.
Right? So you need to remember these numbers and you need to remember this commands like U, G, O, plus minus equal to. So you'll play around with this one. And this is a regular job that you do every day in, day out. Right? And
Yeah.
chmod 750 and the directory name. You can also give 7 is 4 plus 2,
Read, write, yeah,
read execute.
yeah, everything.
And here this is write execute. No, sorry, read execute, not write. And 0 is for others. Others cannot do anything.
Hmm.
Now, right? Now you saw how to change these values, right? How to change
Mm-hmm.
number. Now I want to change these two. See, by default, this is user, this is group, right? I want to change these two. After changing these permissions, I want to change the owner and I want to change the group. So for that, the command is to change the owner, right? The user, right? The command is chown, chown student and app.com. That is, student will now become the owner of app.com file, right? So chown, that is change ownership. Change ownership. We are changing the ownership of this file to student. And again, if you want to change recursively on a directory, chown-r. So the hyphen r is common, whether it is chown or chmod, right? And then you can also use chown to change the group permission. So I wanted to change this group. Okay, I want to change this group, second octet, second column. So the command is chown::admins. So this will change the group ownership of pictures folder to admins. Right?
Mm-hmm.
And there is also one command. See what this will do. Chown.
Changing group and
So visitors will be the owner, guest will be the group.
users.
No, group. This is group.
Oh, I'm sorry, yeah, group.
This is user. And chown, if you don't give username and just use colon and the name. So this is group name. Don't confuse. If you want to change the group name, you need to prefix it with colon. That is mandatory, right?
Mm-hmm.
If you want to change both user and group, then user colon group name and the folder.
Mm-hmm.
Okay? Now, so chown owner and group. You can change these two parameters, chown user and group, using chown command. Okay. There is also one more command called chgrp, change group, change owner. So change group is used to change the group of a file or a folder. Okay. Again, it's up to you. You can use chown to change the group also, right?
Yeah.
So you can use chown single command. Generally, we don't use chgrp because why to use two commands when you have one command? You can go with that, right? So chown is the simple method for us to work. Okay.
Yep.
Right? Now we will see this exercise how we can play around with the permission. So lab start CLI. Okay. So then log into server A. Okay. Log into server A. Okay. Now right. Push this here. Right now, I will log into root account sudo-i, okay, sudo-i, and the password is student. You know, right? Sudo is where this student has been given a root access. When it's sudo-i, it will be able to log in as a root account on the node. Okay. Now create a folder, mkdir so and so folder. Okay, create a folder. Okay. Now change the group ownership of this to consultants group. Okay. In the machine, they have already created consultant groups and they want group ownership of this folder to be consultant. Okay. So first we will check the consultants. Okay. ls-l and home consultant. Again, why is it showing like this?
Maybe doesn't have any. It should, right? I mean, it has to show permissions.
Yeah. So remember, we saw one option, right? For directories, we have to use
D.
D. So if you don't give -D, what happens is it will list the files inside this folder. Because this is a new folder, I don't have any contents, right? It is not listing anything here, right? So if
Okay.
you want to list the, or if you want to see the permissions of a folder, you have to use -D. Okay, so that will show you the permissions of the file or the full listing of the folder. So if you don't specify D, it will list the files inside this folder. That is the difference. Okay,
Mm-hmm.
now the task is they want to change the group ownership to consultants. Okay, now who is the owner and who is the group on this folder now? See, owner is root, group is
Group
root.
root.
Now I want to change this root, the group, the second one. Okay. So the command
Mm.
is chown. Okay. Sorry.
Mm.
Right. So now I want to change the consultant. So what to use? Either I can use chgrp consultants. Okay. Consultant. Right. And then I can give home consultants. Okay. This will work. But again, I don't want to use chgrp. I want to use chown. When you give chown, generally the syntax is username colon group name, right? But my task
Yeah.
is to change only group, right? So I will just remove user and I will keep this same colon as it is because when you keep the colon, right, the chown thinks that okay, it needs to assign this to the group. So if you don't give colon, what happens if you don't give
Maybe
colon?
it takes everything as a.
No, it will assign this to user. You got the
Oh
point?
yeah.
Exactly.
Yeah. I
The
got it.
purpose of chown is to change ownership, right? But
Yeah.
when you put colon, it as thinks, okay, this is a group because this is the second one. If you don't give colon, it changes this one. That is the difference. Okay. So chown colon consultants and then followed by the consultants. Okay. Now if you type ls-ld, see from root it changed to consultants. Right?
Mm-hmm.
Now after that, add write permissions to the consultant group using the symbolic method, not numbers, right? So I want to assign write permission to group. So again, for permissions, the command is chmod, and I want to group, and I want to add write permission, okay, and then
Mm-hmm.
/home consultants. Previously, now what is the current permissions on this consultants folders for group? See,
Is it? Yeah, execute and read.
read execute. That's it. Right. So when you say read plus write, what do you see now? See RWX. So it did not disturb the existing read, right? It just
Yeah,
added the write. Okay. So the consultant group has read, write, and execute permission. Okay. Now this is one.
mhm,
And then now how for other users you want to remove everything, right? So use the octal method, right? So for others you don't want anything, so it should be 0, right? But what is the current situation on the file now? 7, 7 and 5, right?
yeah,
Right. So now chmod, okay, 7, 7, because I don't want to disturb this existing permissions for users and groups, and I want to remove this. So it is 0, 0 and home consultant. Okay. So chmod 770 and slash. And if you hit enter, ls-l, see rwx, and others has nothing.
yep,
Right? So commands are there. Only thing is you have to decide what command you want to use. Right? Right? That's it, and that is how. Right? So you exit this, and then now on the same server and machine, they want to log in as consultant one. There is already a user login to consultant one. Okay, the password is Red Hat. Okay, log into consultant one on server A, and they want us to create some files inside this directory. Okay, now change to this directory. Okay, change to this directory, and then touch consultant1.txt. Okay, now ls, I have consultant.txt, and where I have created inside home consultant. And why did it work? Because I have given 777 for the group. Okay, and the group is consultant. So this user's consultant one is a member of this group. Right? So that
yeah.
way you are able to create the file. Okay. Now after this, the next thing is switch to the second consultant. Okay, I will exit and then switch to consultant 2. Okay, and password is Red Hat. Okay, and then you create one more file. Okay, cd home consultants, go to this directory, okay, and create one file. Okay, now if you type ls, you should see two files. This file was created by consultant 1. This file was created by consultant 2, right?
Mm-hmm.
Now exit this. Okay, exit this. Okay, exit this server A, and then, right, that's it, right? So now what we have seen here, two things. Users can go to this directory and create contents as per their requirement. That is because I have assigned a group permissions on this folder, and I have also said that the group, whatever is the group here, the users in this group will be able to read, write, and execute. Okay,
Mm-hmm.
just give me a minute. Okay. So now, and because of the permissions, the users will be able to write the contents inside the common folder. This is a common folder, right? So I can write it,
Mhm.
right? So that is how you can play around with the permissions. Okay. You can exit this server A and then you can finish this lab. Okay. So now, what are the commands that you have learned? First thing is here you have chmod chgrp. Okay. Okay. So here you learned about there are three categories: user or owner. Generally, we call user. We don't call owners, but again, these are interchangeable. Next is group. Next is others. The others is O actually, not zero. Others, right? So now the notation is UGO, and if you want to include everyone, so it will be others. Others with
Mhm.
A, all users, right? A is all users, and this is how you assign the users. And to assign the permissions, you can use RWX, where R is read, which is 4, W is write, which is 2, and execute is X, which is 1. When you sum up, the total is 7. So for every user, every category, you have 7 value, which is 7, 7, 7. So based on your requirement, you can assign the values, right? You can change the group name and username on a file using chgrp or ch own. Okay. So basically, chmod is for permissions. Okay, permissions, right? And here, change on change grp is for user and group allocation. Okay, so chmod is to assign permission, on chgrp is to allocate user and groups to the respective file or folder. Okay, so this is the one that we have covered in this slide, right? So this is fine. And then yeah, and then let's continue. Okay, just give me a minute, Vijay.
Yeah, sure.
Yeah. So next, we will see how to manage the default permissions, and there are special permissions. Now, again, security is the biggest question to any company, right? In terms
Mm-hmm.
of permissions, like simple, I mean, not only Linux machine, like if you work in a company, uh, security is a biggest, not only not in terms of operating system, even the building access, building management, room access, right? Data center access. So those are all plays a vital role, right? So whether it is a operating system or whether it is a physical premises, everything has a security issue, even including your mobile phone has a security issue, right? So people are focusing more on security, and then they are incorporating those policies based on the latest technologies, right? And now there are a lot of scammers who are calling and they are doing a digital arrest and a lot of things, right? For that,
Mm-hmm.
they are, uh, companies, governments, they are all putting extra efforts like sending OTPs and other kind of extra layers that they are putting so that to just safeguard their customers, right? Same way, you have these permissions, right? So far, you have seen these permissions, right? These are there from the beginning, right? But still,
Mm-hmm.
this might not be sufficient in some scenarios, and you need extra permissions. And this permissions also has some sort of limitations. So we will look at those limitations. What are those limitations? And then those are addressed by the special permissions, right? So again, the special permissions again are for user group and other. Okay. So if you observe, you have this X, right?
Mm-hmm.
Let's say, let's draw again, let's me write, okay? Uh, RWX, RWX, and RWX, right? Now,
Mm-hmm.
here, your special permissions, I'm talking about special permission, okay? Probably I will right here. Okay, so this is okay. If it is better if I write here, so special permission. Okay, okay. Special permissions. If you look right here, X, this X, this X, those will be replaced. Okay, those will be replaced by SUID, SGID, and then I think others is sticky bit. Okay, sticky bit, sticky bit. So these are the three permissions that are uh, used for extra privilege. Now, when you assign this particular bits, right, and this goes and sits in user execute permissions. Okay, user execute what you call what is called octet. Okay, and here this SGAD will sit on group execute octet. Okay, and sticky bit will sit on others. Okay, so others execute octet. Probably I'll give X so that you understand. Execute octet. Okay, so this X, and this X will be changed when you assign SUID, SGID, and sticky bit. Now, what is the purpose of this and why do we need it? Okay, SUID. So, file executes as the user that owns the file, not as the user that run the file. Okay, generally in a team, there will be some scripts which someone has written already, right? Those scripts will be there. And let's say I have joined the company recently, and they will give the SUID bit on that particular file. What happens is that user, whenever I execute that script will be executed on behalf of the owner of that file. and it will perform the activities. Now think logically, why do I need this? Why do I need this?
Maybe just for the I mean, security thing, right?
Okay, so now I'll give you a real example. Now let's say here, yesterday we have seen the user administration classes, right?
Mm-hmm.
Where is your user information saved? In etc password, right?
Mm-hmm.
Where is your password saved? It's in etc shadow,
Mm-hmm.
right? So, and who owns these two files? Slash etc password. Who owns that file?
Root.
Shadow. So your password file is owned by root user. Your shadow file is owned by the root user, right? And what is this now? Now I will switch to the Arvind account. Okay. Character slash etc password. Sorry. Okay. User add. I will add user. User add Arvind. Okay. I will switch to the root account. Uh, now I will add the user add Arvind. Okay. Now I will switch to Arvind account. Okay. Now Who am I is the command. Okay. I am Arvind account, right? Arvind user. Now, can I change the password of my account?
Of course you can.
Can I change my password?
Your password.
Yeah,
Yes, you can.
I can, right?
Do you
So
want?
what is
Yeah.
the command? Password, right?
Yeah.
Okay. Right. And current password I have not set actually. So let me set that also so that I'll give you a real example. Okay. So now I will exit this and I will give the password as okay. I am changing it as a root account for now. Okay. Okay. Password Arvind and Red Hat, Red Hat. Okay. I've given it as a Red Hat password. Okay. Now I have created a user called Arvind and the password is Red Hat. Now I will email to Arvind because I'm an admin. I will email Arvind saying that, okay, your account has been created. Username is Arvind and password is Red Hat. Right? And I will also mention a note that, okay, once you log in, please change the password as per your requirements. That is my message. Okay. So then what I will do, I will log into my account. Okay. I logged in and I have to change my password, right? Because administrator knows my password, right? So password password and then enter. You can just enter as enter because by default it will take the name with which you have logged in. Otherwise, you can give Arvind also, right? And if you hit enter, what do you say? The current password. What is the current password? Red Hat, right? Hat. And what is the new password? I will say welcome. Okay. I think no, I think uh, actually probably I'll say okay. Welcome at 123. I think I need to, because of the security, I need to give a lengthy password. So Red Hat, I will say RH199 at, okay, even I don't remember. Arvind, no, not Arvind, I will say, what should I give?
You
Uh,
can just give Red Hat 1 2 3 4 5.
No, that is not taking.
Exit
That's because of the security reasons. So what I
password.
do is probably I will type so that I remember. So what I will
Style.
do is I will say RH199 I'll say at Red Hat. Okay, that's how many characters I have. 6, 7,
More
10,
than 8.
11, 12. I think this should take, let's see. Okay, RH RH199 at the rate Red Hat. See, that's because of the complexity. So
Mm-hmm.
RH199 at REDHAE. Done.
Hmm.
I was able to change the password. Now, based on your experience, like what we have done the class yesterday, right? Now, when I change the password, where it will update the password, in
In
which file
the
it updates,
uh, etc. I don't remember the path
it
exactly.
is shadow, etc shadow.
Shadow, yeah.
Now let's exit this. Okay. Now I will say cat slash etc shadow.
Hmm.
Okay. Now remember this is the one which it has updated, right? Encrypted
Yeah,
password. Now who owns this file? etc shadow.
it has to be root.
It has to be root. But what is the permission here?
Nothing.
Nothing. But as a Arvind user, how did I change my password? How did it write my shadow file? See, when this file has been written, 12:13.
12:30.
What is the date? Time now, 12:14. 1 minute back, this file has been written because that is Arvind who modified, right? Now,
Hmm.
even though I don't have permissions, how did I change my password? Okay, so that is because of the SUID. So he mentioned, right? Execute files as the user that owns the file, not as a user that runs the file, right? Now, what is the command that you have used to change the password? Password, right? So
Hmm.
ls-l slash user, where is the password executable? Okay, which password? Okay, and bin password is the command, right? That's
Hmm.
the full path, absolute path. So
Path.
ls-l slash bin and password. What do you see here? The permission.
Read, write.
Read, write, you have yes here. So
Hmm.
I told you, right? Your SUID will sit on execute octet, group execute, others execute. So SUID, you will see S here. That is RWS. And here RWS. Right? Now you correlate what we have learned. This is an executable which has SUID, and who owns it? Root.
Root.
Now, as a root user, when I use this command, because it has SUID bit, it will run the script as root user and then it updates the shadow file which doesn't have the permission. Clear?
Yeah.
Right? So if you see here the statement file executes as the user that owns the file. Here in our case, the shadow files is owned by the root account. When I run this bin password command, that when SUID bit is set, it runs this script using the owner name, not your name, right? And then because only this shadow file can be written by only by the root user, not by any other user. So SUID will help you to modify the files based on the SUID bit, right? So this is one of the best
Hmm.
example for SUID. right?
Okay.
Now, similarly, we have SGID. File executes as the group that owns the file. Same logic, but this is for group, this is for files. Okay, so this one we can do it manually, which we will see in the lab. Because this is a bit too hard to explain SUID. So that is why I explained now. SGID we will see in the lab how we can test this SGID. Similarly, you see O plus T. So here your sticky bit will have R, W, and T. That is sticky bit. Okay. So generally RWX, RWX, RWX. But if you have RWS, RWX, RWT, then you have SUID, SGID, and sticky bit set on the file or a folder.
Okay.
Okay. Now again, what is sticky bit? Sticky bit users with write access to the directory can remove only files that they own. So when I have a folder, common folder, right, which is shared by multiple team members, and you have written a code and it's a 1,000 line code, when you put that file, in the common folder, someone might delete that because they are jealous, right? So to avoid that one, you can set sticky bit on your file so that only the owner of the file can remove it. No other user can remove it. So that is sticky bit.
Oh,
And this sticky bit should be given only for a folder or a file which is shared with multiple team members.
okay.
Okay? So that is sticky bit. Sticky bit is not to remove. SUID, SGID is execute the files based on the user permissions and group permissions.
Okay.
Okay.
Got it.
So that is how, see, this is an example. Let's say that bin password, it has this one based on this, it changes the permissions of the file. Okay. Likewise, you have many examples. See, LSF and LD where log journal. The journal has the R and S at the group level. That is, this journal, this group will be able to modify the contents of this particular folder or file.
Okay.
Okay, right? And again, we'll see an example. Don't worry, in the lab so that you'll understand. Right? So SGID, SUID bit, it consumes the execute position will be changed to yes. Right? Similarly, T is sticky bit.
Sticky.
So that is only the owner can delete this file. No other user can delete this file.
Okay.
Okay. Okay. So again, there is a value. See, sticky bit is 4, SUID is 4. Okay. So SUID, the value is 4, and SGID, the value is 2. And then the right is again sticky bit is 1. So again, the count is 4,
7.
2 plus 1, 7. The total is 7. So generally, now you change, now your permission would be chmod, okay, 7777, and the file name.
Only 3 sevens, I guess. Okay, okay. First, it's two.
Exactly.
Okay, got it.
Right?
Yeah.
This 7 stands for your extra permission, SUID, SGID. So if
True.
you give 4, where your if you give 4, where it will write? It will write in the SUID. If you give 2, that is, if you give 4 here, it will update the SUID. If you give 2, it will update the SGI. If you give 1, it will update the sticky bit. If you give 7, it will update everything.
Okay.
And if you give 6 here, it is SUID, SGI. Then if you give 5, it is SUID plus sticky bit.
Execute.
So depending upon the permissions, you can change the values. Right? So that is, and again, if you, this is octal notation, this is symbolic notation. Symbolic is U plus S, G plus S, O plus T. Right? Here it is 4 and it is O plus S, right? O plus S, sorry, U plus S, U plus S, and this is G plus S, G plus S, and this is O plus T. Right? So this is octal notation, this is symbolic notation. You can either use this or you can use this also, anything. Okay. Again, example C, CH mod, again the command is CH mod, G plus S. We are assigning SGID on the group. U minus S, we are removing the sticky SUID from the user. So here, don't think it is a hyphen, it is a minus, right? So we are removing the sticky bit, sorry, we are removing the SUID bit, we are adding the SGID. And same thing I told you, right? 2770 or 7770, you can give all the values here. Okay? And this is how the default one. I mean, if you don't create by default, whenever you create a file in your Linux machine, it gets this number 666. So when you say touch file name, by default it will get read, write, execute, read, execute, read, execute. And for a directory, it is 777. Now, if you observe, what is the full value actually? The full value is 777, right? Right? And what did they say? File, when you create, what is the value? 666. 666. And for a folder, default, when you create a folder, the permission is 777. Okay. Now, how will it create these permissions on the file or folder? Because they have a concept called umask, user mask, right? So by default, you have 777, right? So what is the value if you remove 666 from this 777? What is the value? It is 111, right? Right? See, the default is 11777, right? The full permission is 777, right? But when you create a file, it says it will get 666, right? So when you minus this 777 from 666, what should be the value? The value is
111.
111. Similarly, if you remove 777 minus 777, the thing is 000. Okay? So this difference is called UMask. The difference is called UMask. Okay? This UMask value, literally, I mean, you can think of this UMask value will be removed from this full permission. And that is the one you get to the file or a folder. Okay, I think there should be an echo dollar UMask. Okay, I think no, I think UMask. That's a command. Okay. See, what is your UMask? 0022. So this is one of the kernel parameter. So when you create a file, it will remove 2 and see 7 minus 0, 7, 7 minus 2, 5, 7 minus 2, 5. So you will get 7, 5, 5 as the permission. Got it?
Yep.
That is your UMask. Of course, you can change this UMask and all those stuff. That is an advanced topic. You can change it also. As per your requirement, you can change it. Right? But UMask is nothing but a value which will be removed from your full permission value from 777. That is your UMask. Okay. See, if the UMask is 022 effects on the file, what is the permission?
Read, write, read,
644,
read.
get execute. Similarly, 027, 00. So again, you can change this UMask, you can change, you can give the UMask and you can give whatever you want. Right?
Mhm.
Right? So based on that, you can change the UMask values and UMask is covered. And if you want to change the UMask temporarily, just UMask and 0227, the default UMask will change to 0027. But this is only temporary. When you log out, this will reset to this again. Okay. If you want to change that, you need to put this in the etc login.deps file, or you need to put this in etc bash rc file in your local profile file, so that this UMax will be applicable to everyone on the in the machine.
Mhm.
Again, this is all customization. We call this as hardening, server hardening. So when we do server hardening, like whenever we install the operating system, we don't directly give it to the developers. We first harden them. So we harden again. There are some standards called CIS standards, and there are some standards which we need to follow, and we need to harden our server, and then we need to give that server to developer, and then he will deploy the application. So this UMask is also one of the hardening that we do in Linux environments. Okay. Okay, so that's how we play around with the symbols. Again, there are n number of permutation combinations. You can play around with those permissions. Again, don't worry about this numeric binary options. Okay, so we don't work on binaries actually. We work on symbols and octal notation. That's it. Don't worry about these numbers, zeros and ones. Okay. Right, again, don't worry about all these numeric values, and these are all the different methods. So you have to read this document and explore, understand this what we have discussed, right? So you need to remove this UMask from that particular octet, and then you will get the files. See, initially the file will get 666. The UMask is 022. When you remove 22 from 666, the permission is 644. That is how you get. This is the final result of the permission. Right? For directories, 77 is default. We remove 0022 and the permission is 755. Right? That is how you create the permissions. Right? And then if you put 0, what will happen? You must 0. The file will have read, write, execute to everyone. And mkdir 0, you'll get 777. So nothing will be removed.
That's
Right?
for temporary.
Temporary, right? But generally you will not give this. Again, based on your requirement, you can change those values. Again, these are all practicing. You can practice by changing the UMask temporarily. You can create files and see how it is behaving. Right?
Hmm.
In the UMask, create a file and check the permission. That's how you can learn.
Okay.
That too, you create a file and you create a directory, to see the permissions. Okay. So we'll see this guide exercises. So lab start, permissions default, okay. And then I will exit from root. Okay. Okay. So now what you do is you log into operator one as operator one on server A. Okay, login, right? And then create so and so folder and verify. So mkdir create a folder. I have logged in as an operator, okay? And then I created temp operators folder. Right? Now change the group ownership of the temp owner directories to operators group. Okay, so ch own group owner operators and temp owners. Okay, so I am changing from before that I can also check ls-ld/temp operators.
LD.
-ld.
L. Mm.
Okay, so it is owned by operator and operator. So now I will change that to operator. See, from operator one, it changed to operators. Okay, so the people inside this group, the users inside this operator groups will be able to read, write, execute the contents inside this folder, right?
Yeah.
No, so this is fine. Verify operator one user default umask value and it is and list the permissions of the things. So umask, okay, you run umask and the permission is 007. That's a umask which is default set. Right. Now verify the permissions on the solution which we have already seen, right? Of LSF and LD, those things, operator and operators, and that's fine. And read, write, execute. Group can have read, write, execute. Ensure that files created in the temp open directories are owned by the operator group. And then verify the ownership. Okay. Now, before doing this, right, we will do some testing so that you will understand. Okay. Uh, right, that is fine, that is fine, we will go with this one, right? So now what I will do is here use symbolic notation to configure the sgid. So they're asking us to configure sgid on this folder. So the command is chmod g plus s and so and so. How do we give symbolic notation, sorry, octal notation? SGID is 4, right? I forgot. SGID is 2. So 2770. Either you can give that or you can give chmod g plus s. Okay, on operator. So once you run this command, okay, and if you say LSF and LT, you should be able to see RWS, which is sticky bit. Assign on these operators, right? Now, if you observe, now ensure the user right access, that is fine, that is there. Now, use octal notation to configure the sticky bit on temp operators. So now you have configured the group, that is operators can create files, and now they want us to assign sticky bit, because users should not delete the other users files in the folder. Okay, how do we do that? And they want it in the octal method. So what is the value of sticky bit? Sticky bit is 1, right? But
Mhm.
previously I have given sgid, right? So it should not be disturbed, right? So 2 plus 1 is 3. So what I will do, chmod 3770 on this operators. Okay, and if you say LSF and LD again, see, yes, you see yes at the group level and T at the others, which is sticky bit. So users, the group, the people, the members of this group can create files inside these directories with their own names, and no one can delete the other users' files, right? That is sticky bit, right? Now, create as an operator one, create the user, so and so user, sorry, create a file. Okay. So currently there are no files in this directory, right? ls-l temp operator, there are no files. Now I will create this file as an operator one. And if I say ls-l, what do you see here? The owner is operator one because I created this file using with operator one. And what is the group? Operator groups. So both operator one and operator group can read write. Okay. So now whichever user who creates a file, right, they will get their ownership on the file. Okay. And then again you go to this and you type lsfnl, you should be able to see this one. Right? So temporarily change the UMask. They want us to change the UMask. Okay, so I'll go to this cds temp operators. Okay, now they want us to change the UMask to 022. Okay, change the UMask to 022. Right? Right? Now create a file name so and so touch so and so. Okay, right? And ls-l, what do you see? You create a file and others has read, but groups write has gone, right? Because of the UMask value, right? And also you observe this group ID has been removed and sticky bit also been removed because you change the UMask of the files. Again, as I told you, right, not only this training, if you go to any training, like it can be DevOps or Kubernetes, Docker, Linux, Ansible, everything, right? So
Mhm.
you will learn lot of things in bits and pieces, right?
Yeah.
User administration, you will learn 10 commands with 10 different types of use cases, right? Now in real time, they will give you a scenario, right? I want to create a folder, like as an example, and where I want that to be shared with 10 users, but I don't want them to delete each other files, and every file should be owned by that particular user. Whoever creates the file should have that particular owner. They will give you this kind of scenarios, right? Now they will not tell you what to do, how to do, and what commands to use. No, they will give you a scenario. You need to gather all your knowledge on user administration, the commands, whatever you have learned in the trainings, whatever you have learned in YouTube, chat gpt, whatever it is, right? Collect everything, come to a conclusion, verify it in a test environment, and then you implement it in production. So that is how you need to use. So you have n number of ways, n number of comments. It's up to us to decide what matches our requirement. Based on that, you can proceed with any command. No one will ask you. Right? So whether you use UMask, whether you use now see, after setting everything, the logic is if you set 002, what is 0 in the first octet here? That is to remove SUID, SGD sticky bit, right?
Yeah.
Right. After setting up this chmod, G plus S and O plus T, if you do UMask like this, then there is no use of these two commands, right?
Yeah.
So it all depends upon what you are doing and why you are doing. You need to put question yourself, right? Why do we need this? Why did we run this? So based on that, you will get answers. Right? So, but the challenge is, first of all, you need to understand what is UMask, what it will do, what is chmod, what is G plus S, O plus T. So if you know that, you can play around with these commands. That is why fundamentals are important. Right? So that is now touch. They want us to create touch. I think we created, right, OPC file to it removed the sticky bit. Right? Now that is fine, right? Now login as operator 2 and the password is Red Hat. So now switch to Red Hat. So switch to operator 2. Okay. Now, now you try to remove this file, the file that your user has removed. the operator one user has created, right? So you cannot delete it because the sticky with permission prevents users to delete the file, right? So here, when you assign the permissions, when you change the permissions, now if you delete file 2, okay, right? What do you see here? The file can be removed, right? See, it asks you for an option. See, because you have already set the sticky bits and you removed using as SUID bit, still your file is being protected with SGID because they will not be able to remove because you've already set the SGID bit. And so this by this way you can restrict user to delete the users so that they can create the files. They can safeguard their files. But again, the logic here is I cannot delete the file, but I can empty the file. Okay. Yeah, that's there. That's still there. Okay. That's why the reason is people don't will not allow you to keep files in the machine. You should put that in the Git repository so that you have version control. You can recover those files, right? So again, right? People has lot of you know uh, ways to screw up things, right? So we need to restrict them by imposing these kind of regulations, right? So that people will say integrity and all those stuff in companies, but no one follows all this nonsense, right? So especially in our cases, like we don't follow, right? So when we ask users not to do this, they will try to do that to see what happens, right? That's a default tendency, right? So we have to put this kind of restrictions so that at least we don't have to blame them. We have to make sure that they don't do any nonsense when they join a company, right? So that's the precautions that we take, right? So that's how things work. Again, if you close one gate, they will come. Okay, they come up with a different options, right? Right, that is how the security is nowadays. It's getting hardened, right, everywhere, right? Because if you now let's say especially banking sector, so now they previously we don't have OTPs. Now they incorporate OTPs because people hackers is easily able to find out the passwords. Then they set OTPs. Now when you set the OTPs, what hacker did, hacker is trying to hack your phones, and then he tries to forward that SMSs to his phone, right? Or he will call you and ask you to forward that OTPs, right? Because of that, now instead of OTPs, nowadays they are giving the app OTPs, not the SMS OTPs. So you can get the OTPs or approve the login only through apps, right? So based on the issues that you encounter daily in real time, you need to impose restrictions or you have to enhance the security. Likewise, nowadays, Linux also is now getting more restrictions, like it is trying to impose based on the real use cases. It is adding more security levels to enhance the security of the operating system, right? So it's a continuous learning process. So you have to go with the flow and learn the latest, technology. That's it, right? So that's it, and then you can finish this lab, right? So all these are basically related to your permissions, uh, which is an extension of the user administration that we have seen in the last class, okay? Right? And this is the lab, full lab that you guys can practice. Okay, this is the full lab. Whatever we have learned in the last in the whole chapter, right? This is a cumulative lab. They will give you some scenarios, so no new concepts. So use the knowledge, whatever you have learned, and then try to implement. And here they will give you solutions as well, right? So practice the solution. Okay, and that completes your chapter 5. Okay, and then. Next is installing RPMs. So we will see RPM installation in the next chapter, next topic. Okay.
Okay.
Yeah. So yeah. So tomorrow is Wednesday. Wednesday, Thursday, Friday. Okay. Let's see. Yeah. Oh,
So,
yeah.
yeah, apart from this, like I don't know, Arvind, like I have like two challenges. So
Hmm.
one of the thing is like I'm not able to. Let me quickly share my screen, okay?
Okay. Let me stop the recording.